Alright, welcome back. Now, everything that we've said so far in these previous parts of the lecture have been about the aerosol direct effect, how aerosols themselves interact with radiation that's moving through the Earth's atmosphere. But aerosols also have something called an indirect effect. The aerosol indirect effect has to do with the fact that aerosols can work in the Earth's atmosphere as cloud condensation nuclei. You might remember that term from like ATS-113. Formation of clouds and cloud droplets usually requires a small suspended solid in the Earth's atmosphere for the water vapor to condense onto. Generally speaking, water vapor doesn't just condense into pure little liquid water droplets, it tends to condense onto little aerosols in the atmosphere known as cloud condensation nuclei. So human activity has increased the total amount of aerosols in the Earth's atmosphere. It has therefore increased the number of them that can be serving as cloud condensation nuclei. You might think that that is a pretty straightforward answer here, like that'll mean more clouds or something like that. But it's more complicated than that. Changing the number and composition of these aerosols changes the property of the clouds, the properties of the clouds. In particular, changes their drop size distribution. See, clouds are made up of liquid water that condenses onto the available cloud condensation nuclei aerosols. If the air is relatively unpolluted, it still has hundreds of aerosols per cubic centimeter. But that's a relatively small number of aerosols, and so you will have the same amount of liquid water condensing onto a smaller number of aerosols. You'll get a smaller number of bigger droplets of liquid water in a cloud. Like that diagram there that's labeled unpolluted air. Okay? Per cubic centimeter of the air, there will be a smaller number of larger liquid water droplets. On the other hand, air that is polluted and has a lot of aerosols in it of anthropogenic origin, be they black carbon or whatever, will have lots more aerosols in it per cubic centimeter. The same total amount of liquid water will condense onto a larger number of aerosols, each individual one of which will not grow as big. So when you have air with more aerosols in it, you get clouds that have about the same amount of liquid water in it, but it's in the form of more smaller droplets. You have changed the distribution of droplets in the cloud. Now, that actually has a very important role with regard to shortwave radiation, actually long wave too, but we're going to focus from right now on the shortwave radiation aspect of it. Clouds that contain a larger number of small droplets, rather than a small number of big droplets, the clouds that contain a larger number of small droplets are generally more reflective. They have a higher albedo than clouds that contain a small number of large droplets because they are unpolluted. And there is a classic example of this, ship tracks. Here is a picture of a deck from a satellite. This is a deck of stratocumulus clouds out over the ocean. You see all these stripes in there? Those stripes that are in there are paths that diesel-powered ships took under that layer of clouds. When the the air where you see where the clouds kind of look darker, the area between those tracks right there, that is where the air was pretty clean, and the clouds that formed there have a small number of a smaller number of larger drops in them. Meanwhile, wherever the stacks from the ship were putting diesel, the aerosols from the combustion of diesel, most notably sulfates, because there's a lot of sulfur in diesel, into the Earth's atmosphere, now you have lots of aerosols to work with, and you get clouds that have a large number of small drops, and they are more reflective. So looking at this cloud deck from above, you can see how there's some clouds seem much brighter than others because they're reflecting more shortwave radiation. This is the aerosol indirect effect. The aerosols that the ship added to the clouds, by adding aerosols to the otherwise clean air, have way more tiny droplets in them and are more reflective. Well, there's a climate implication here, right? If the clouds are brighter when the air is more polluted, brighter as in they reflect more shortwave radiation, that is a negative radio forcing. We are reducing the amount of shortwave radiation that is getting to the surface of the Earth. Now, in the case of ship tracks are a classic thing to learn in like basic meteorology classes. You look at them and you're like, oh my gosh, it's amazing how you can see exactly where each diesel-powered ship went under this layer of clouds. Classic thing. But the truth of the matter is we're not just making the air less clean and more burdened, the right word is burdened, with aerosols. under those ship tracks there, we're doing it everywhere. I mean, it's dramatic and impressive in the case of ship tracks, but the truth of the matter is all clouds are getting more and more reflective of shortwave radiation because of this aerosol indirect effect. As we add more aerosols to the Earth's atmosphere, overall clouds are getting be made of smaller droplets that reflect more shortwave radiation, and that has a climate implication. Now, that is not the only thing that aerosols can change inside of a cloud. They can also change, like, for example, remember back in ATS-113 you learned about how it rains. You had to learn about the processes that cause cloud droplets to grow into raindrops and so on. That can all be messed with depending on how much aerosols there are in the Earth's atmosphere. They can change things like the heights of the cloud. They can change the amount of the cloud that is in the form of ice versus the amount that is in the form of supercooled liquid and so on. All of which can result in changes in like how much long-wave radiation the cloud emits and absorbs, how much short-wave radiation the cloud reflects, and so on. All of which gets lumped together in the world of climate science into this idea of the aerosol indirect effect. Now, that aerosol indirect effect has a net effect of cooling the planet. It is a negative radiative forcing. Overall, the main thing that those aerosols are doing in an indirect sort of way is making clouds more reflective, which sends more shortwave radiation back into space before it even has a chance to warm the planet. So the direct effect of aerosols was to cool the planet because mostly those aerosols were reflecting shortwave radiation. And the indirect effect of aerosols was to cool the planet because it made the clouds more reflective. So the total aerosol effect is you add those together and it's a whopping negative 1.2 watts per square meter. That's a pretty big offset of the global warming that's caused due to the radiative forcing of greenhouse gases. I mean, the total, it was like right around 3 watts per square meter due to greenhouse gases. We've offset a big chunk of it. Wow. Yeah, remember, actually I didn't remember I had a slide here. Remember, the total radiative forcing associated with the greenhouse gases was about 3 watts per square meter. So in this sense, those aerosols are good. They are keeping global warming partially in check, but they're air pollution. They are emissions. They are a significant health problem. They have environmental impacts. In general, we don't want them there. And as it happens, especially the ones that come from, okay, in the West, we have largely regulated a lot of those away. We're more careful about things like the emissions from a coal-fired power plant. We can require that they put scrubbers on the smokestacks and so on, so there's less particulate emission. We can require that diesel be cleaner and have more of its sulfur removed and so on. In the world that we live in today, a lot of this aerosol burden comes from China and India, where they are not yet very far along in regard to their implementation of ways of getting rid of this particulate matter. But that will change. Okay? China and India are signatories to international treaties to gradually phase in rules that will reduce their emission of particulate matter from like coal-fired power plants and so on, and to switch to cleaner diesels and so on. And as that happens, the total amount of aerosols in the Earth's atmosphere will start decreasing, and this total aerosol effect will start getting closer to zero. For lots of environmental reasons, that's a good thing, but from the point of view of global warming, it's a bad thing, because global warming will be accelerating, because we will no longer have this effect that is partially canceling it out. That's bad news. Hey, by the way, if you actually take a look here of a map that is from satellite images, this comes from the IPCC Air 5, you can actually, there's a way we can use satellites to determine the optical depth of aerosols in the Earth's atmosphere. And you can see that so this is how much radiation is being emitted, is being absorbed by the aerosols. Being reflected by the aerosols in this case. The optical depth can be used to mean reflected as well. Think of it though as just sort of a map of where the aerosols are, and you can see that like eastern China is a major source of these aerosols. India is a major source of these aerosols, and also like desert regions of Iraq and Saudi Arabia, and then you see the Congo. Well, you also see the Sahara and so on, but like also tropical West Africa and the Congo, that's from biomass burning. Alright, yikes. A lot of scary stuff about aerosols. Now we have other effects that we're going to be talking about in the next part of our lecture, but let's answer a couple quick questions first. Question 9. The presence of anthropogenic aerosols in the atmosphere generally blank increases or decreases the number density of cloud droplets, liquid water droplets in a cloud. Number density is in how many there are, like per cubic centimeter or something. And that blank increases or decreases the cloud's albedo. What does the presence of anthropogenic aerosols do with regard to clouds? Make a choice from those 4 combinations and get a little feedback before you move on to the next question.